Hi. So I want to talk in this video about designing a control circuit that would be used to drain some type of tank. Now this is a really common application for sump pits. So if I'm dealing with a sump pit, especially in a commercial environment, think about underground parkades, anything like that near the water table, what they'll do is they'll have a sump pit in the basement where all the drains will drain into. What'll happen is the water inside that sump pit will fill up. When the water inside the sump pit reaches the top, it drains that pit out into the sewer system, right out into the drain, out into the river, wherever it goes. So think about this tank, right? So the tank, all the water's rushing in from my parkade, snow's melting off cars, it's filling the tank's gonna start to fill. Now once the tank reaches the top, the water level, or near the top, we want to start a pump, right? So we'll have a little pump here, which will have a hose and it'll, feed that water out, right? So when our water reaches the top, that's when we want to start the system pumping. So we're gonna place a start switch at the top of the tank. Let's think about how we want that switch to work. As the water level rises, we want that switch to close. Therefore, we need to use a normally open switch. So as that water level rises, that switch is going to close and start the system. So that start button will be our high level. Now let's think about, we start it, the water's draining, it's going down, the pump is running. As we reach the bottom of that tank, now we need a switch to tell that pump stop running. So we need a low level switch to stop the pump. It's really bad to run those pumps dry. So when we reach the bottom, we want a switch. As the water level goes down, we want a switch to open when the water reaches a certain point. So we're going to use, again, a normally open switch. And that's going to be our stop at our low level. Now, because that switch is a normally open switch, when the water gets low, that switch is going to open and turn off that circuit. So both our switches, our start and our stop, are going to be those normally open switches because that's what we need them to do in this situation. Water level rises, the stop will close, it'll stay closed, then eventually it'll reach the top, that start or high level will close, which will start the system, which water will then pump down and out, and then it'll stop, right? Over and over again, an automatic process with no user input. So let's put that into our drawing, okay? So we have our stop, which we said was a normally open switch, or we called it our low level. That's when we want it to stop. And we come over to our start, same thing. Normally open switch, that's our high level. Connect that up to NEMA 2 on the left, connect that to NEMA 3 on the right. So that's what our control circuit would look like. And now this is a very simple system, right? We're operating with a single pump, a single start, and a single stop. What you'll really often see in the actual application of this is you would see multiple starts and multiple pumps. So you have a little bit of a redundant backup. If one pump fails, there's still a second pump that can run. There also might be a controller in place using something like a smart relay very often, or an alternating relay, which will switch between the pumps so only one of them is running, then the next one runs, then the next one runs. If we reach a high level or a second high level, both pumps can run, or we can even hook it up into an automated system to send out an email to any maintenance workers or anything like that. This is just kind of the basics of how you would want that control system to work. Thanks for watching.